heritage buildings have various passive cooling strategies which have thick walls that have high thermal mass, high ceilings, courtyards and verandas, solar shading devices such as jalis, canopies, still and moving water for evaporative cooling, and natural ventilation by means of wind-reduced flow to cool the indoor along with the efficient daylighting and we all know that Taj Mahal uses number of passive cooling technologies that keep the interiors parts of this well-lit area, and these are the jalis used dome walls with high thermal mass. This is something which is radiating the entire energy to Yamuna bed and unfortunately we have not done any work in measuring how this energy is moving, and that is a pity where MEP consultants and architects have not talked to each other. We have documented them very separately. We all know Hawa Mahal in Jaipur has 953 windows known as jharokas that maintain air ventilation that keeps temperature low. But this Venturi effect and how this is happening is unfortunately again not documented by all of us. We all know that this beautiful fort of Amer of course has fantastic passive design strategies which includes various elements such as hydraulic engineering, architectural integration and detailed urban planning. We can see that specifically when it is completely elaborated in underground chambers where multiple passive strategies design elements can be found located as wind tunnels, water walls, ponds, cisterns, thermal mass, and this is all done 400 years back. So we have to really understand why we have not brought this into our regular projects. I belong to Indore, so we are very fortunate that this particular plateau had some fantastic, incredible water management systems, which includes several bowdies, several channels. There are 1200 small ponds completely integrated with each other. So friends, when it comes to historic buildings and are to be preserved and renovated, and we saw some wonderful presentations earlier, the occupancy or integrated use is often changed from the original, which can require alteration of buildings. So in this particular situation, MEP systems are often redesigned either to accommodate the new building use or because the original systems have become so damaged or inefficient that the replacement is the best action. In many instances, a historic renovation project will require new heating, cooling, electrical, lighting and plumbing systems, but the design of these utilities is often restricted by the architectural and historic character, defining features that should not be destroyed or damaged. So design of historic preservation is therefore usually more complex than designing a new building. With thick walls, multiple level complex layouts, hidden voids and complicated structure, heritage buildings were never designed initially to accommodate modern systems. A challenge which is common to historic building is the need to place devices in inaccessible places where ensuring effective coverage and allowing for future maintenance. So old buildings have often neglected wiring. In many cases, installation can be done at floor levels to facilitate the power flow. Of course, in the digital age, a lot of challenges are coming up. The lighting, however, proves to be more problematic, and these systems inevitably means disrupting walls and ceiling, and the very feature that needs to be preserved. Electrical and air conditioning installation can also create aesthetic problems along with structural challenges. Each MEP system Each MEP system has unique design challenges while renovating and preserving the historic building. The design problems can arise when a renovated heritage building would require more electrical load or power to supply additional electrical features. If supplementary electrical power is needed, then the new electrical system and equipment such as transformers, switchgears, panel boards might need to be redesigned and installed in the building. Routing additional conduits and making rooms for additional electrical equipment can be design challenge in working around the architectural features. Firstly, on the plumbing side, many older buildings might not have fire suppression system or fire rated valves which requires to be added as per the current building codes. So it is very difficult to bring building up to the current fire safety codes while still maintaining the historic characteristics. If a new fire suppression system is to be installed, it will usually require new piping and penetration in the structures. And when redesigning the plumbing piping consisting of hot water recirculation, cold water, sanitary water and ventilation piping, vent piping, which will all need to be coordinated with architectural features and structures. So plumbing equipment such as pumps, hot water heaters, backflow preventers also will need to be allocated space in the building. The stormwater drainage can pose one of the most difficult design issues if rooted within the building, and it could be very difficult to integrate and coordinate the large stormwater pipes with existing MEP routing equipment and the historic character of the building. On the mechanical side, the system often will be the most difficult for MEP system to design because it will require large sizes of equipment such as air handling units, chillers, boilers, and the mechanical system, if located on the roof, can have to be architecturally covered up to keep the attractive appearance of the building. Routing of ductwork can be an issue when not enough space is available in plenums or when original architectural feature or thick walls inhibit the desired routing locations. In some instances, historic buildings might not have a central system. Then routing and required space will be also an issue because lack of provision of original design. So another common HVAC issue for historic structure is the change in humidity levels. This can cause damage to or deterioration of materials also. Installing or upgrading HVAC system for historic building is not only the greatest challenge, which involves balancing comfort, efficiency and preservation. Each historical building is different and no type of HVAC system will work, no specific type of HVAC system will work. So water systems including hydronic radiating system, fan coil units and radiant pipes have the advantage as pipes can have much smaller diameter than HVAC forced air ducts and therefore easier to install. So there are a lot of projects where we are using radiant system under the floor. Water systems where however come with the risk of hidden leaks and bursts, both of which can damage the surrounding areas to introduce moisture to delicate collection. So this is a high risk system, but it is a probable solution also. Central air system allow for high degree of climate control and many can have their condensers located outside which may cause severe damage to the structure appearance. We just now seeing what Chandigarh experience of Ms. Abha. I think she narrated her experience and could be a very big challenge. So adopting modern mechanical system to historical building will need careful planning and coordination. We have done some small duct systems offer a better solution. This is a special system which is now currently available in the globe, where we use 2 inches flexible tube, and this can be integrated with VRF system also, and it can be integrated with the chilled water system also. I will be showing you some good case studies of this. So no matter what type of HVAC system for historic building is selected, it should meet ease of service and maintenance, inclusion of humidity monitors and safety systems to protect collection, installed with future upgrades in mind. installed with structural limitation of the building and minimum level of vibration and noise and visual compatibility with the original architecture. Small duct high velocity system are very efficient, and I will once again take you through on one of the case studies, but this is the Darbar Hall of Udaipur Palace, where we have penetrated 48 inches wall with this system, and it is working now for last 11 years successfully. The larger air handling units will always have challenges, but what is now happening is to overcome these challenges, now mobile and wireless technologies are becoming very common in field of heritage building. Today, smart innovative solutions for historical building ranging from lighting to security to fire systems are easily available in the market. Smart security integrates features like access control, CCTV, alarms, panic buttons into one easy use system. In recent decade, wireless sensor networks, we call it WSNs, and Internet of Things techniques are broadly utilized in cultural heritage protection oriented networks or for monitoring the environment, security improvement issues. The wireless sensor network is a monitoring system comprises of radio equipped nodes linked to suitable sensors. These radio frequencies are now determined by government regulations, but they are permitted, and the sensors capable of monitoring crucial parameters like temperature, humidity, masonry cracks, pouring rain, and usual light for heritage building protection. So a lot of things can happen with these smart systems. A WSN comprises a set of intelligent nodes and each equipment with a radio transducer for wireless communication and ultra low power microcontroller for data pre-processing and flash memory to store the data. So the nodes automatically connect to each other through wireless links to enabling distributed data processing and remote data transmission. On the fire side, the wireless fire devices have become very highly specified solution for heritage building, overcoming most of the challenges and pitfalls that these complex structures can prevent to fire systems, specifiers and installers. A wireless system can be installed in hours and devices can be easily moved to or updated in future, allowing system to be expanded, modified or upgraded as building use evolves and technology develops. There is no complexity and structural impact of running wiring loops for installers, less disruption of visitors attraction, reduced cost and less need for intervention in the historic fabric of the building. More and more these buildings are in operations in year round, so wireless is the best choice to deliver an effective optimal fire system. We now have smart lighting solutions available. The beauty of wireless lighting is that it involves minimal installation, often utilizing existing sockets, and it is controlled remotely via smartphones or tablet. It does not require any concealed wiring. Also, the walls and ceilings of heritage buildings remain untouched, and lighting can be positioned wherever necessary throughout the space. Wireless lighting also offers significant cost-saving benefits, reducing waste energy by 50%. This advancement is going to happen further because there is a huge advancement happening in battery technology and LED lighting, which means wireless systems can run for many years without even battery change. The passive technologies take advantage of local environment to maximize the comfort while minimizing the energy use and adverse impacts. So the passive design principles should be developed and integrated with the current advanced technology to overcome the challenges. We have some fantastic examples which India has. India's largest passive controlled building is operational for last 14 years with the energy consumption of 1/9. This is something which Ahmedabad has for Torrent Research Center. We are working on a largest net positive campus of the country at Nalanda with architect D.V. Doshi's office, and here we have also adopted several such technologies. So we have adopted modern technologies and blended with traditional wisdom of architecture which we have learned in India. So here we are using all the aspects of modern technology. Friends, I was fortunate to work with this Fateh Prakash Palace, the Heritage Hotel at Udaipur. This is one of the most beautiful sites I have done any project. We have been fortunate to get global awards for this project because this was the first project in the world where we used digital technology in terms of ERVs with very innovative high velocity duct system. The Fateh Prakash so this was the presentation which we had done in detail. I don't want to get into it, but what we have tried to do is remove the current condensers which were lying in the verandas, which was overlooking the palace. You can see this beautiful palace which is from the side of Lake Palace. So, Fateh Prakash Palace Hotel has been certified as Best Heritage Hotel in Heritage Grand category by the Department of Tourism. And what we have done here is we have taken out from those corridors which you see here and taken outdoor units to the other building. With the result, the owners could get 6 rooms overlooking the palace. And these are the best rooms of Udaipur, I personally feel. They have been fantastically done, and entire advantage came because we could remove this to 300 meters away from the current location. And we were fortunate to get some tunnels which were connecting the 2 palaces, and this was very effectively done here. This was the Darbar Hall again here. We did not touch the current old heritage structure and integrated a VRP system along with specially designed for this architectural framework, special units which were probably nobody can even visualize where the units being located. So this was all possible because of good working with architects. You can see here this was a corridor on which old condensers were lying, and they were converted to a luxurious rooms there. This is how the piping was moved, and we took the units almost 300 meters away. You can see here the 2 inches ducts were integrated with the architecture, and you can't see them. Also the outdoor units which are seen on the terrace were beautifully covered. Of course, our entire opening sizes and everything was designed by us, and architect did respected that, but you can't see those condensing units from anywhere. So this was something fantastic application which we worked out. There were many challenges in the kitchens. Of course, these were resolved with floor raising, but this is one of the largest challenge which building, if it is not meant for that, and particularly in heritage position, this can have a lot of challenges. So this is a second job which I would like to showcase here. This is done in your city of Jaipur. I was fortunate to work with Ahmed is architect here from Lambah. This is Lambah Palace. So Lambah Palace is most glorious of palaces with its elaborate splendor, extravagantly decorated hand-carved marble jalis, sandstone balustrades and cupolas and chhatris to complement the magnificent rooms and elaborate Mughal gardens. A fantastic project is this, and this is a banquet hall which is recently completed. You can see our air conditioning grills are not conventional; they have been integrated with the interior. And the services was a big challenge here because they were not to be seen, so we have created a complete underground tunnel to take all engineering services, and at spots wherever services were required, we came up. This is a beautiful tunnel work which has happened with all smoke, ventilation and everything taken care. And this is how you can see the structure because nothing was to be seen from the outside road. And how we have done the ducting integration is very interesting because we had very limited space for ducting, and the grills were very specific shapes So you can see multiple levels of ducting happening there, but it was very nicely integrated. And this is one of the most challenging job which we have done in our life. And the result is very, very heartening. And you can, of course, go and see this when you are here. There were large utilities which were taken care in terms of air conditioning plants, in terms of our plant rooms. All that integration happened. This is something which is just done. This hotel is just commercially starting in the city of Jaipur. This is a Hyatt Regency hotel which is just completed, and the beauty of this is, of course, blending of all your heritage designs. And here again the services was very challenging because of the nature of work which was demanded by interior designers and architects and Hyatt chain. But you can see here again entire heritage architecture was blended with our engineering services. So this is just finished work. One of the recent openings in Jaipur. You can see here, of course, we didn't get a tunnel here, but we used terraces. But you can't see any services anywhere from the outside areas. So that is, and it has big services because it is a pretty large size air conditioning system. So friends, I am here in Jaipur as ASSOCHAM GEM chairman. So ASSOCHAM has taken a green initiative to take care of Mother Earth and to complement India's sustainability movement, and they have formed this Council of Green and Eco-Friendly Movement. We call it CGEM, that executes GEM sustainability program. And GEM has 5 ratings starting from 0 to 105 above is our GEM 5 certification. We use a yard scale of 0 to 135. And GEM is becoming very popular because it is very reasonable, and our GEM certified building will give you a payback of maximum 3 to 4 years. We are now present across the country, and we have 2,000 plus professionals helping us for this. I am very glad that ASSOCHAM GEM Green Building Certification Program has been impaneled with Rajasthan Building Bylaws 2020, and free extra FAR incentives on green buildings are available. It is also heartening that Maharashtra government has also given similar notification recently. Also, Kerala has done this fantastic work, and the ASSOCHAM GEM Green Building Certification Program is now empaneled in Government of Kerala. Also, Delhi government state level expert appraisal committee is insisting for ASSOCHAM GEM. So I think we are started getting good recognition. I am very glad to put on records that recently completed 2 new stations at Habibganj, which is now Rani Rupati station, and also Ahmedabad Gandhinagar station is certified by GEM 5. This is a luxurious hotel standing above the Leela Hotel. There are many projects which have come forward. Sir is here. His corridor at Dharkar side is also GEM certified. We are very glad that we have now signed 93 MOUs with several universities, and our dream and passion is that we should teach our architectural students about sustainability. So these are 93 institutes and universities with whom we have been working on GEM sustainability program. So friends, let's please and create a green, environmental, sustainable country and take his mission forward. And heritage is our legacy from the past, and it is our responsibility to preserve it. I know MEP is a very challenging subject for this. We heard many remarks earlier, but I wish this is debated in much bigger depth. This subject is of immense importance if we want to preserve our existing buildings. Thank you so much.
One question I had.
Yes, sir.
He is a very good teacher. That's why, I always listen to him very, very consciously. And he's a very pioneer in MEP, very innovative. Thank you very much, sir, for your wonderful presentation. Sir, I am just very loudly thinking that about heritage, we talk about conservation, and when we talk about building conservation, we still use very consciously lime and surkhi to retain the heritage and the conserve the building. Can probably we look for MEP which was there at that time, and we practically bring that back, bring back history into the heritage and try to see that how the great palaces were functioning in a cool and comfortable position without any HVAC, without even, I will say, lighting arrangement, without many other things put together, but they were probably most sustainable palaces of the world.
Thank you for that excellent question. I think you touched my heart. Basically, these all buildings are done, say, 400 years back. The way we lived then and what we are doing today and the way we are living our life has changed. The lifestyle changes have brought this probably requirements of change. You know, today, those days lights were not there, and now the electricity is there. So how do we complement that? So I think engineering systems will be a need if, because the transformation of technology is going to flow to these buildings. We are not going to live the way we lived 400 years back. So I personally feel we can't be going back to that level, but certainly we should learn, and there is no denial about it. To me, sir, we have not documented and we have not done research in terms of engineering and understanding what is happening. I just was telling you that how much energy is, say, flowing from Taj Mahal. It can be digitally mapped today, but we have not done those efforts. We don't even know what thermal mass is created, which can give that effect. So there is no marriage which has happened between architecture and engineering. And Yatin sir is here. He's from SEFT. I've been telling now Vimal also that this time has come that we start doing this. You know, our own projects, such wonderful buildings. If that orifice diameter of Hawa Mahal, if we can map that and understand what velocity of air is giving what cooling, it can be now done, but we have not done it. So I think I have also challenged our ISHRE, which is Indian Society of Heating and Refrigerating Engineers, and I've been requesting them that whatever work we do on technical side, if we are able to, in our generation, at least this could be a 5 years project, but if we can do that, I can assure and James can work with ISHRE and with architects like you. I saw many eminent architects. I think this is something which we must do. And if we are able to document that engineering, we should be teaching world. Why should a architect from US come and tell us what net zero building should be and how it should be designed? It is our legacy. I think we should be ashamed if somebody comes from US and tells us what is that. Or I must tell you, sir, Yatin sir, जब ये तोरण का प्रोजेक्ट हुआ था, तो सर ने मुझे बुलाया था आर्किटेक्ट सामने कि पंकज, will this work? Because he told me very one simple thing, Nimit sir. I'm talking about Nimit ji. He is no more with us. We lost him in COVID, but he has done some fantastic work in this part of the country. And when he was designing this Torrent building, research building, I was quite young. I still remember 28 years back. He said, Pankaj, the client is appointing a consultant from UK to design this, and he showed me the sketches. So do you think it will work? He's giving him more fees than what he's paying to architect. That was his pain also. So the moment I saw that, I told him it is going to work. So he said, how did you tell me in 1 second? I told him, sir, when I was kid, I was traveling to Mando many times. And in Mando we have this Rani Rupati Mahal, where when we used to take our guests there, the guide will take us to terrace level and he will put 1 drum of water into the courtyard, that kind of a pond it was. It had sandstone below it. And you believe it, within half an hour when we will go down, after listening to his stories, there will be air draft, beautiful air draft. And that used to happen because it had a double wall which was extended about 6 meters. But the story guide will tell us that, you know, the Rani Rupmati was so beautiful that king didn't wanted anybody to be seen from outside, so he had made those walls, but they were acting as a draft. They were taking the draft up. The courtyard with the sandstone was giving the air with a higher density moisture, and the breeze used to be getting created. And this is exactly we were doing there in Torrent with a high mist system. We were creating a mist in the courtyard, and we had those towers which you saw, and those were taking the draft up. So I think this is how I think, how many second or third building have come after that? This is done 14-15 years. I feel bad that nothing has come after that. So I think we should have got many more buildings if it was working. And I have done work now. Recently I did about six lab areas in this building, and I see that the system that does work with this 45 degrees. You are able to maintain 32 degrees without any additional power. What else you want? So,
sir, we must have a very conscious approach, because some architectural documentation of historical buildings are done, maybe it takes a little more. But MEP documentation is very, very poor stage in the country.
Correct. That's what I am saying, sir. That's what I am saying, that maybe my fraternity has to be blamed for that. We have not.
No, all of us.
Collective responsibility.
Collective responsibility. A time has to be done.
सर उसको नहीं वो NDC को वोट हाईजैक कर गया ये करके.
Thank you, sir.
Nice presentation. Thank you, sir.
Characteristic of architectural materials, and that is architectural materials analyzing and bringing that